Good day. Today, I would like to present to you a transportation, engineering, pavement, and geometric design. My name is Sibongiseni David Kanyile. Aim of the project. As the students, I've been tasked to design a conceptual upgrade section 13 of R33 from 60.8 kilometers to 63 kilometers in Valwater town in Limpopo province. This will be a four-lane divided road with sidewalk. I am expected to generate a final alignment by utilizing a commercial available geometric design software. For this design, the pavement structure is given as 4A wearing course, 150 base layer, and 200 sub-base layer. For this subgrade design, the road section can be assumed to be uniform with average C per R of 11.5 and a standard deviation of 1.06. The road the road category is Tier RH Class B. Design will include the following: alignment design for at least 3 kilometers, but not more than 4 kilometers. Detailed manual calculation of vertical curves and also horizontal curve. Completion earthworks design and mass hull diagram. Concept design of stormwater drainage system such as side drain. Their client objectives are to improve geometric and layout of R33, which is the road of the proposed road, improve the safety and capacity of all road and non-road users, improve the safety road crossing to cater for heavy vehicles and current stop alongside the road in safe and controlled manner. The site's locality. R33 is a provincial road that travels via Valwater to Greytown to connect with Pietermaritzburg and Lephalale. It's a very long road that travels across the provinces of KwaZulu-Natal, Mpumalanga, and Limpopo. The R33 starts at the crossroad with R10 near the junction of south of Lephalale. To begin with, it travels east to across the Mokolo River. The project is the project roads is situated inside the Mohodod local municipality limit, which is part of the Waterberg district municipality in South Africa of Limpopo. Motivation for an upgrade. It is clear that the section of 13 of R33 have exceeded its maximum span, hence there are visibility, severe cracks in the pavement structure. The initial project brief was to upgrade the 60 to 63 to ease the congestion delays while improving the safety of road users such as pedestrians and cyclists. The road network plays a vital role in the economy of any country, and maintaining infrastructure at a level that serves the current traffic needs is a critical element. Now we'll look at the topography of the area, which is the site is located toward the western boundary of Limpopo province between the elevation of 1,000 1,113 and 1,315 above the sea level. The study area represents the average slopes of between 2 degrees and 6. Now we'll look at the site status quo investigation, which include the water recirculation and also the sewer recirculation. There is a municipality line pipe that runs along R33. This pipe is contiguous by pipe markers and also valve chambers. For sewer recirculation, there is no sign of formalized sewer recirculation in the vicinity of the proposed development. A resident of the area was asked to confirm that they use a septic tank in the area. The nearest possible municipality connection will, will be along the, the R5110, where there is an existing complex serviced by municipality. For environmental consideration, um, an environmental specialist was appointed to advise on the impacts of matters that will arise from environmental legislation, such as climate, topography, and also drainage, which I've just mentioned. Estimated present traffic. Traffic study was conducted before from the information obtained from the municipality, which assisted in the design of the existing pavement based on ADT, which is 650 vehicles per day, and over analysis period of 20 years. And the recommended pavement class for this road was class B. Design criteria. Design standard guidelines. These are the documents that we use. I've just mentioned them, which is I'll just count a few: geometric design projects for highway, geometric design for railroads, geometric design for manual SANRAL, which is a SANRAL document, and also the drainage manual, which is for drainage system, which is the sixth edition. Pavement design is as follows. The proposed layers are as follows, which is the A A4, A40, A40 wearing course, and also 150 G2 base layer, 200 sub base layer, 150 G7, which we calculated from the CBR, and also 150 G9, which is the rib and recompact in situ material. Design conceptual design is that we're gonna use, including the standards, which is the standard drainage manual, standard specification, and also the following document which will assist in terms of designing the drainage system. Now we'll look at the road surface drainage requirement. Road surface drainage can be achieved by taking into account the following surface slope. Road surface drainage in this road will be achieved by using the curb and channel combination. Reducing the erosive power of water can be achieved by reducing its velocity. To minimize erosion, the road surface must be hardened or protected in such a possible as much as possible. Road reserve drainage requirement. These are proposed culvert that were proposed according to what the study that was done, which are 5 culverts as shown on the slides. Now look at the most important part of the project, which is the horizontal alignment and the vertical alignment. I've calculated the curve length adequacy, which was okay. According to what we calculated, um, it was based on what we obtained from the previous projects. And also I've also shown the Excel calculator using the Excel as well for accuracy purposes. In terms of the CBR, have obtained 10.141% for CBR, which will um, show me which will give me the layer works and also um, the pavement structure. These are the three sketches of the pavement structure that I've designed according to the the CBR that I have calculated previously, which is the 40 wearing course, 40 wearing course, and also the 150 for base layer, 200 sub base, 150 upper selected layer, treatment of in-situ upgrade. Traffic investigation analysis reports. Before designing any road, it's very important that you do your traffic investigation and analysis reports. At this point, we found that the provision of an effective, sustainable, and economical design solution that would cater for traffic needs of the community hinges on the understanding of traffic flow within the project area. The road traffic assessed is aimed as follows: assessing the current traffic patterns and also the composition of the entire road section, providing the forecast of 20-year design horizon, assessing the current public transport operations, and assessing the future public transport infrastructure needs, assessing the current non-motorized transports. For this road, I adopted the software called Civil Designer. Civil Designer allows the designer and analysis of complex road, earthworks, sewer, water, stormwater networks at all time, upholding the realistic design model in which all relevant infrastructure elements are spatially and geometrical associated. For road reserve requirement as classification, according to TR26, road update may fall under Class 4B, which collects a road, commercial road. Class 4B road provide the right access to larger property, such as business, industrial. Class 4B intersection control allow a relative high percentage of heavy vehicle buses, hence the traffic signal and modern roundabouts and priority controls are appropriate. These are the cross-section elements of the proposed road as follows. Now I will explain the procedures that were followed when the road um, when I was designing the road. I first activated the terrain to allow the importing of coordinates and also okay, and also showing the range of coordinates, which is y, x, and z. Um, and also creating the project after inserting the coordinates. After inserting the coordinate, then I generated the contour by interval. Thereafter, I generated the horizontal alignment and also the vertical alignment and adding the points of intersections, which is the PI of the roads, displacing the points of, here I was displaying the point of the intersection of the road and also intersecting the design model and our road design as well, which is very important as well, the road marking procedure. And and then I added the base layer as instructed in the project brief. This was the design that I've designed for road, which entail the details on the project reports. Thank you.